All right, everyone, it is now 3:30, which means it's time for us to get started. Welcome back to another lecture of Comp 426, Modern Web Programming. This is lecture 8. So I'll give everyone a chance to settle down so that we can get started with announcements, please. Thank you. All right, so to get started here with our announcements, if my tool connects, if not, that's fine. So again, great job on the midterm. We had that on Thursday. Already graded them. The average was above an A, so amazing work for everybody. Grades should be out later, either today or tomorrow. We have some makeup exams that are happening right now for those who are sick or absent. So great work there. And kind of on top of that, so today we're going to be starting a new module. We're going to be working and jumping headfirst into React, and we're going to be working with this tool now for the rest of the semester. So to kind of support this week there are two supplemental, well, not supplemental, they're assigned readings. And so reading 4 and reading 5, they're open on Gradescope. One is due Friday, the next is due Sunday, but both are open now. So you can go ahead and complete those if you want. That way you have no work over the weekend. This will be a very good this will help to discuss a lot of things and build upon what we'll be talking about in lecture, and it will be helpful for future assignments as well. All right? Any questions here? And then another note, I do not have a graphic for it, unfortunately, but this weekend is the Carolina Data Challenge, which is our data science hackathon as part of our department. And there's a lot of development there, as well as with the School of Data Science. So if you're interested in attending that, learning more about data science, I believe if you go to the course, if you go to the UNC website, the CS website, there should be information there if you want to register. I think it'll be a great event, so highly recommend it. All right. So to kind of recap here, what we were talking about over the last module, the first kind of 3 weeks of the class, right? We talked about developing web applications using these tools, right? So HTML and CSS for developing our user interface, TypeScript, and in addition, just JavaScript in general as we perform our conversion there for functionality, right? Making sure that our site can actually do things, respond to events, load data, etc. And then we connect these two things. We connect our functionality and our UI using event handlers. So that way we can interact with the UI and we can run some code, add some functionality to our site. And then maybe that would also in turn affect the UI as well. Right? And so this is historically, back in the day, as the web was emerging, this has been the way that websites have been developed using these 3 fundamental tools. And they really are the building blocks of the web. Even though these days we use a lot more modern tools, ultimately what is sent to the browser is just HTML, CSS, and JavaScript, right? And so for smaller websites, you can still develop websites this way, where you just use HTML files, CSS for styling, and then have some JavaScript or TypeScript code that connects some functionality to our UI. There are a few challenges, though, with this approach, especially as we scale up. I would like you to consider Pixel Art Maker, which is your second assignment that you all worked on. You set up a lot of event handlers, right, to get a drawing on a canvas to work. And admittedly, this assignment was probably somewhat tedious because you had to set up all of these event handlers. You had to make sure that they were connected to the right UI elements, that the functionality that you're running ends up correctly running when some event happens on your page. And this can really be broken down into a few major, 2 major challenges that are kind of all the challenges that you may have thought about we're working on. Pixel Art Maker kind of fits into these 2 categories. Right? The first one is this idea of keeping the state. State is a term that we use a lot in computer science. But in this case, you can kind of think of it like the data behind your app, right? So keeping the data of the app and the UI in sync was an involved process, right? Every time that you updated or you clicked on a cell, for example, you had to update there's a 2D array in the back for the canvas that stored all of your colors. You'd have to update that, and then somehow you'd have to also re-update the UI to match what that array would represent. So this was a bit of a challenge. And so I want to show this in a diagram. If you have A02, feel free to open it up or go to GitHub and pull up the code, because I think this will help you to kind of put in context here what you all kind of did, since it's been maybe a week or 2 since we've worked on this. right? So you can see here in my kind of graphic, that's like my grid. That's the grid that you saw in Pixel Maker, except this time it's 8 by 8 instead of 16 by 16, just for diagramming purposes, right? And so this, what you see, is the UI, or sometimes this is known as the view. Right? This is what the user actually sees when they use the site. And this was defined using HTML and CSS. So that is our UI. Right? And if you remember that as you worked on this project, there were two main TypeScript files that you worked in. The first one, and I know the text is a little bit hard there to see, but that is your main.ts file. So you can go in there, you can pull it up, and you'll see that it is there. This particular file included things like event handlers, which is the top box in case you can't see it. I know for some reason today, I feel like the projector's colors are a little bit more muted than usual. So it says event handlers. And then you also had a function in there called sync canvas. If you go to main.ts, it might have been called officially in the assignment like sync canvas with engine. Might be the full name of the function, but I just abbreviated it here. And then underneath the main.ts file, you had this engine, the engine.ts file. And this engine code was responsible for storing your actual canvas data. So you had a 2D array here for a canvas that stored all your colors. And then you had some paint functionality, right? Paint took in a row and a column, and that is what updated our canvas. Right? So what happened here is imagine that we wanted to paint on a cell. So I click, maybe I have green selected as my color, and I paint on one of these cells. Right, so let's say that that is the cell, I think that's column 2, row 3, that I wanted to paint on. Right? What happened here? Well, when you click on this cell, we end up triggering an event handler. Right? So there's some event handler in main.ts that you created that connected each individual cell to some paint functionality. So over here, an event handler is triggered. Right? And then from here, the event handler would call in the engine our paint functionality. So in our engine, it would say paint cell. It would take the row and the column that you clicked on and pass that in as RNC. And then our paint cell function would then update the canvas. So I know it's kind of hard to see there, but there's a little green dot now. It kind of represents a green color being put in our 2D array representation of our canvas. Right? I want to pause here, though. Right? Now you notice that when we made this change and our canvas array updated, right, our view, what the user actually sees, has not yet updated. Right? All we have done is we have drilled down through the stack of files. We have changed the color in our engine for that cell, yet our UI has not yet updated. Right? So the data underlying our app and the actual UI here are out of sync. They are not, like, changing my canvas does not automatically change my UI. Right? So what I have to do now is I have to do one more step, and you all implemented this in Pixel Art Maker. Right? So that function, that paint function, would return back to the event handler. Right? The event inside of the event handler, you called paint cell, that returns. And then we called this sync canvas method, or it might be called, again, sync canvas with engine. What happens here then is this particular function call will check our canvas, which is our 2D array representation in our engine. And then it's going to go through all of the tiles and recolor them to match our canvas 2D array. So it will go through all of the, in this case, 64 squares, and update it so that it matches what we stored in our canvas. So you can see that after all that long process, we got a situation where we now have a green tile that has been painted on my screen. Right? You can see that that process was pretty involved, and we had to make sure that we manually went ahead and synced our canvas afterward. If you forgot that sync canvas with engine call, your UI would essentially never change, even though the canvas, like 2D array in the engine would. And so again, the underlying idea here is that we needed to manually update the DOM to reflect the new state or the new version or new representation of our data in our canvas. Any questions here? All right. So again, this was our first challenge, this idea of keeping the data under our app and our actual UI in sync. right? This we were able to do in Pixel Art Maker, but you can imagine in a really large app, maybe an app even with more pixels, or maybe you're thinking of some app like Amazon's website, or maybe some game that you have, like a web game, then keeping track of and managing our data and keeping our UI in sync with that data can be a challenge manually using the approaches that we know. And in addition, if you happen to go into the HTML, which you may have done, the HTML was pretty cluttered. Right? Our grid was 16 by 16, which means that we had 256 individual div components that were added in our HTML. So again, to show you what this looked like, if I went in here, and I don't know if this link will work for you, if this is it might, because this is repository is part of our class one. We'll see. Right? You can see here that we have, and this is very hard to see. So let me see if I can go ahead and fix my appearance here. Well, let's see. I guess changing to light mode did not do anything. Anyway, I'll zoom in so that it's maybe a little bit more clear, right? And again, apologies for the lighting, but you can see that we have over 100 individual divs. Each of them have some ID that's like R and then the row _C and then the column, right? So that is pretty unwieldy. And that's just for a 16 by 16 grid, right? So you can imagine that if we were to build larger websites with hundreds or thousands of elements on them, which a lot of websites we use do, this would be really challenging. Right? The biggest problem here is this idea of composability. We cannot really create custom HTML elements that we can then repeat. Right? This is a very common abstraction that we use in computer science in a class like 301, where you abstract functionality out. Right? Instead of repeating functionality, maybe we use a loop, or maybe we create some object and then repeat that. Right? That's a very core idea to computer science to essentially reduce this duplication. But the way that HTML is set up is there's no way right now to create these custom elements. And so therefore, you're ending up duplicating a huge amount of HTML code. Questions here? All right. So imagine now thinking about just the tools that we've learned, using pure TypeScript, event handling, this type of setup, just HTML, CSS, to create really large applications on the scale of something like Instagram, maybe Twitter, Discord, Netflix, etc. All the many different types of apps that are out there that you use that are really complicated, Twitch or any live streaming site as well, right? You can imagine how complicated that would be to do just using the tools that we know, right? You can imagine there are hundreds, if not thousands, of event handlers per page with thousands of HTML elements and a lot of CSS styles, right? That becomes really hard to maintain and very unwieldy. And so this is why, if you were to go into industry today, maybe as an internship, I know when I was walking in, some people were talking about interviews, so you're probably going through the process, right? Maybe you're looking at some jobs. In the web development world, if you did front end even as an internship or full stack, you probably will not come across a team that's using just writing pure HTML, CSS, and JavaScript. Because, again, for these large apps, it is not a reasonable solution for building large-scale apps, right? And so it's not really preferred in industry. On smaller websites, like maybe a course website or a blog or something like that, it's reasonable because there's not that much going on. But on larger scale apps, it's definitely very unfeasible. And so over the years, as you know, and this is not only with the web world, with any software engineering, but especially with web, right? Over time, as problems begin to exist with current solutions, such as the ones that we have, we will begin to develop new tools, new libraries, or new frameworks to try and bridge the gap and to make development of these large-scale apps easier, right? To improve something we call the developer experience, sometimes abbreviated as DX. Right? That's a very important part of what we're doing. And so one such solution was developed by software engineers at Facebook, now Meta, and it's called React, right? So React is a library. It is a set of tools for developing user interfaces, which is part one, and also second, managing state or the data underneath our UI as part two. right? So you can kind of see that this is correlating with the two main problems that we highlighted with our current setup for something like A02. Right? Now, React is a huge, huge tool. It has over, and this particular number has not been updated, so it might even be higher, over 200,000 stars on GitHub. It is one of the largest projects on the entirety of GitHub's website. It is very, very, very big and very mainstream in industry. Right? And it continues to be maintained by Meta. There's a team at Meta that's focused on React, and there's a lot of also, it's open source, so a lot of people can contribute to it as well. And the main goals of React are these two key pieces, the same two key pieces that we highlighted in the beginning, which are to make UI composable so that we can essentially create custom UI and reuse things so we don't have to just write out a whole bunch of HTML, and also to better manage the syncing of our data and our UI in our applications. Right? Questions so far? All right. So the first one is what we're really going to drill into today, which is this idea of composable UI. Right? And so the main goal that we're trying to achieve with React is to make UI composable. And so React accomplishes this using something called components. So a React component is just a UI element in React. Right? So just like how with HTML, we had HTML elements as our kind of fundamental building block of UIs, in React, you can think of a React component in the same way. It is the fundamental building block of our UI. So to make a user interface, we take a bunch of components and we will add them together. Right? And so the way that these components are defined is they are actually defined from within our TypeScript code, not from within HTML. And how this works is we will create a function, and that function will return the UI that's associated with that component. We'll see an example in a moment. But in particular, what our function will return is something called JSX. So JSX is essentially a syntax extension to JavaScript, and there's also TSX for TypeScript, right? That enables us to essentially write markup similar to HTML, but within our JavaScript or TypeScript code. Again, see an example in a moment. It'll be much more clear visually. But the great thing about this is that it enables us to combine our markup, like our HTML, with our functionality, our TypeScript, into one file. So that one file combines associated UI and its associated functionality into one file. So let's see what this looks like, right? So this is an example of what this might look like. So you can see on the left, we have a function. And again, this is why now you might be seeing, because we're going to be working with these throughout the semester, this is why functional programming and talking about functions is really important, because we're modeling everything in our React projects like functions. Okay? So you can see here that we have a function, and then we return something that looks kind of like HTML, but not really. It's similar. Right? So that is what's known as JSX. You can see here that our component, this piece of UI, in this case called a video listing, it is defined by a function, and that function returns this markup called JSX, which is essentially going to specify the UI for that element. Okay. We can also pass in data into our components, which makes it really nice because we can pass in variables, kind of like how you pass in props in HTML, right? So in a link, maybe you use the href property. In a image, maybe use the source property, right? That passes in some data into our UI. In this case, we can pass in more data into an element. And the good thing with this is that we can pass in any type of TypeScript object in here. So it becomes really, really versatile and powerful. The great part is, as you can see here, is we can also then kind of interweave TypeScript and TypeScript objects into our markup. So you can see here that what I am trying to produce here from the left, this particular component, is some of like kind of what you see on the right-hand side here, right? It's a video listing. So I can take in a video as a property, and then I want to display maybe the thumbnail, the title, the description, and a like button on there. Right? So that's my UI associated with a video listing. And so I can take in a video object as a property. And then in my markup, I can say, for example, right, H3 and P is something that looks familiar. So I can pass in the name of the video to my header, or the description of my video into my paragraph, like so. And this will correctly render my video listing with the data interweaved. Another cool thing here is that you'll notice that we can actually nest components inside of other components. So maybe in another file, I created a like button component. Well, I could use that like button component inside of the markup of another component. This is really, really useful because it allows us to nest elements and kind of create this component hierarchy. This is, again, really useful for reusing our UI. So instead of having to, for example, recreate a like button every time I want to use it throughout my site, I can just make it into a component and then reuse it wherever I want to use it. Any questions here so far? Yes, sorry. You could, so you could create a using the DOM. Yeah, you could create a div using the same DOM dot create element by ID, or sorry, create element div pass in data. But we'll see here in a moment that, and as we work through this, that this particular way of creating our elements ends up being better for different ways. In particular, passing in data, keeping our UI and our functionality in the same file, reusability, et cetera. So you could, in theory, yeah, this is not something that's necessarily completely brand new. It's just abstracting that functionality into a different way. Right? And this is ultimately, again, when I say, and this is good for everyone as well, like in the end of the day, JavaScript, HTML, CSS is what powers all sites. And so really that is our baseline. These tools are just using those things and creating abstractions so that it's easier to manage. A good question. All right. Again, I already mentioned it enables composability. All right, so this is an example of a component. We have a function. It has some input. We return this markup for our UI. And so the question is that if we have all of these components, right, these are all functions. Like video listing might be a function, maybe a page itself, like my entire video list page is a function. Then how do we load a React component to begin with into our page, right? Because right now we're just saying that React are a bunch of functions. How do we actually get it to show up? And so how this works would be something like this. So we would have some initial HTML file. Except our HTML file is essentially an empty shell. So there's nothing really in it. It's just there because, again, every time that we request a website from a server, we get back some HTML file. We have to do that, right? So we get some HTML back. But then when we load our initial JavaScript code, our JavaScript code will grab some blank container element and then fill in a React component in there. That's kind of our starting point. And then everywhere else, we can just use our React component as our page. All right, so again, here you can see at the top in blue, I have a React component. This is our starting point. It says app. And for right now, it just is one single, right? It's not really much in terms of functionality, just a paragraph that says hello world. And then my code underneath, I would create like a root for our React app. And we would then render inside of that container our element. And from there, we will see our React component rendered on the screen. And again, our React component up here in blue can contain many other React components. So even though here I just have one component there, I could have many, many components that are kind of within that component, and we can mix and match, and it would still all render correctly. Any questions here? All right, and so through this step, I also have a note, React will manage the DOM for us and update our UI to essentially match how our component specification. So React takes care of this for us. So instead of having to go in, manually modify the DOM to create elements, React will do it for us. And also in the next lecture, when we kind of begin to expand upon React's functionality and how it makes it easier to modify and use data, this becomes even more powerful. So there's a link here that feel free to open if you would like. This is go.unc.edu/426-L08. So this is another stack blitz that actually has essentially blank version of React set up. And so I'm going to show you kind of how this works. And we'll hook up our React component to our UI together. All right, so open this up here. And again, if I go back to my slide just to so you remember, this is our link. So it's just 426-L08. Okay. I'll wait a minute. That way, anyone who is still typing it can get it. All right. So once we're here, you'll see something like this. And you should see on the right-hand side, nothing shows up because there's nothing in our HTML right now. But what I want to point your attention to is our, let's see here if I can kind of make this a bit smaller. There we go. You should see the source file on the left-hand side in the File Explorer. And so if you open source, you will see 3 files in here. We have our component app.tsx, which is a mapping very similar to the one that we had on the slide. And then we'll ignore student listing for now. And we also have main.tsx. And so main.tsx is our initial file that loads when we load our site. This is what is connected to our HTML. So you can notice here that in index.html, I have a script tag. This should probably be in the header, but this is what the template gave me. So it's kind of sitting in the body, but placement is not too important. You'll notice that that gives us our source. So this is what connects our HTML with our TypeScript. And you'll also notice here that in our body, we just have an empty div. So there's nothing in here right now. And what we want to do is within this div, we want to render a React component, right? So how do we do that? So in main, we want to first render our app component, which should just say hello world. And so we will use the same steps that we specified in our slides over here. So in our slides, we had these 2 main steps where we create our root, and then we will render our app in here. So we use create root, and create root is a function that should be built into React. So if I type in create root, and let me see if I need to, do I have to import this? Okay, so I have here in my official docs, I have the import statement. For some reason, when I was testing this out, I think if you do this in VS Code, it will autocomplete. For some reason, StackBlitz did not want to. So I'll copy this over. It is our import statement from React that allows us to do this step. So I'll go back here. You'll see it in our code. So I'll kind of increase my size here, bring this. Let's see what's happening. Okay, there we go. So I'll import create root. And so now what do we pass into create root? Well, we will pass in our container. You can even see here it says that we need to pass in a container element. And so our container element here is going to be that empty div in our index.html, which is linked right here. Right? We have this div ID root. So using the DOM, what we talked about last module, we can select this by writing document, right, dot get element by ID. Remember, get element by ID allows us to grab an element from our site and use it as a reference in our HTML or in our TypeScript. So I'll type in root here, and I need to now save this somewhere. So I'll just write const root equals. So I'm essentially saving my reference to my root here. And you highlight over, you'll see that the type of this variable or this constant here is root. So this comes from the React library. And then finally, I will write here root.render. And in render, I will then pass in a React component. And so the cool thing with this is that I can use the same JSX syntax in here and just write app like so, as if this was a regular kind of just like how we write in HTML where we have our tag. I'm using a tag for my React component called app. All right. The only other thing here, note, is that this needs to be imported. So I will import this file from here. So this is just, again, a relative import app from my app.tsx file. And you'll see here on the right-hand side now that I have my UI rendering on my screen. All right, so this is a very basic example where I have my single component, I render it, and now it is available. Questions so far? All right, another thing that I can do here is I can continue to add on to this. So let's say I want this to be a div instead. Whoops. Close. Right, so again, this is some syntax that you might have to kind of get used to because it's a little bit strange in the beginning. But we are, again, just dropping in markdown, markup, very similar to HTML directly into my component here. Or sorry, into my, yeah, as in my return statement. So I can paste in, for example, again, hello world in here, and it will render hello world. I can add other elements in here too, like a paragraph. This is a test. And you'll see that we begin adding on to our component. Right? So this is pretty cool. Any questions so far? Now what I want to highlight is kind of expanding on this idea and going to where we can start adding in some props or some properties. So in my student listing.tsx example here, you'll notice that I have a similar setup. I have a function. So again, with all of our React components, they are functions. And so you can see here that I've created a function called student listing. And student listing takes in two properties. It takes in a name, which is a string, and it takes in a major, which is a string. Right, you can see that right here. I have my type props. That can be anything I want. I can add on more properties to this. And then I just have a very simple div that places our name and our major as paragraphs. Right? So the cool thing is that this is a React component now. And so from my other component, app.tsx, I can use my component from the other file in this particular component here, right? So that I can nest components that way. So I can write in here student listing. And the way that this will work is student listing will require me to pass in those properties, just like we would pass in props into regular HTML. So if I highlight over this, you'll see that it says we're missing name and major. So I can type in name. And the syntax for this is that we will use these curly braces to pass in some JavaScript here. And I'm just going to pass in a string. So let's say I pass in my name here. And we need major as well, which can be here computer science. Right? So right here, you can see that I have used a component from my other file in this component, and it renders on my screen. And the good thing about this is that I can now reuse this. So if I want to have many student listings, like so, it will work and it will display all of them directly just by copying and pasting that component. Right? So if I were to have done this without React, I would have needed to have an individual div and an individual paragraph for every single name and major combination. And so I would have probably in this case, let me count here, 6 individual divs and 12 paragraphs, right, in my original HTML. But now with React, I can reuse this particular element. Okay. Another great thing about this is that I can also iterate over a collection. So in this particular case, I'm going to demo this, where instead of just copy pasting, because I have JSX, which is this kind of hybrid between HTML and JavaScript, I can make a loop and create a list of students by iterating over a list. So in my component, I can write in here like const names. Let's say I have my name. I'll add some of my TAs who are here today, like so. So these are 3 individual names. And then I can iterate over this in my HTML, or sorry, in my JSX. So I can write here, and the syntax again, you will read the syntax in the reading, so it may seem a little bit wonky, but you'll see it again. I can write names here dot for each. This takes in a higher order function that has name here as a input. And so then I can just take the student listing. I'm going to delete all these, paste it in here. And I believe I need parentheses, which again, you'll see why later. And I then should be able to take my name and replace it with name here, like so. And I believe I have a syntax issue, so I'm just checking to see where this might where this might be here. Let me see if I just do something like this. This might be fine. Let's see if I'm forgetting something. I think I can also try something like this. It's not necessary, but well, I forget the exact syntax here, so I'm making a bit of a mistake. But ultimately, this type of syntax will work. So I'm going to, when we do our example, I'm going to double check exactly what I'm doing wrong. I think I'm blanking on one thing here. But again, the cool thing is, and you'll see this again, that you should be able to do something very similar to this, where you can iterate over a collection, and then you can display a bunch of components based on that iteration. Okay, so I'm going to comment this out. We'll come back to this so that I remind myself what I'm doing wrong, because I think I'm very close, but it's my suspicion is something with my parentheses. So I will get back to that. Another thing here, though, that I want to highlight, which I think is really useful, is the fact that we can also essentially do what we would do with event handlers, but do it just by passing in a function directly into a React component. So instead here, if I go back to my name here, and I were to instead write, so I'm expanding this out so it's a little bit easier to read. In React, we can use something called the on, actually, I'm going to do it inside of here, so it's easier. On click. And on click is an example of setting up an event handler very easily using React. So the way that React works is you have a prefix on, and then you have a bunch of HTML or DOM events, so like on click, and we can pass into on click a function that we want to run when we press on our element. So this essentially allows us to combine an event handler with our UI in one file without having to set it up separately. So I can create here like a function called action, which just says alert. And let's just say that we alert our name here. And I can just pass in my function action. So now if I press on my name, you'll see that it pops up an alert that says my name here, right? So luckily that demo worked. So this is an example again of using event handling, but within our component and in JSX. So that way we don't have to create a separate file, manage all these event handlers separate from our HTML, where we kind of have all these references using like a document of get element by ID, and then we hook it up. We can just do it directly on our element here. So there is really no confusion in how we go about setting that up. And as we manage it with larger and larger and larger apps, it becomes easier to work with. Are there any questions here? All right. Perfect. The main thing here that I want to highlight, and as we begin to learn about React, you'll see this, is that component-based UI and the way that we have set it up helps us to transform the way we think about user interfaces. We go from thinking about UI as the static predefined HTML file into kind of this, into different pieces, into components, where we take UI and related functionality, we wrap it together in components, and then we can use them, reuse them, compose them, etc., as we wish. Right? It makes refactoring much easier. We can refactor our code just like we would in a classic 301, where you refactor to get rid of repetition, to use composition. We can do that here as well with our UI. And so we can also then begin to conceptualize our UI in the terms of a component hierarchy, where we essentially have a bunch of smaller elements that might be inside of other elements, right? It creates like a hierarchy of UI. So what I'd like you to kind of think about here is with a partner, so in the last 3 to 5, or in 3 to 5 minutes, there's also a Gradescope submission for this. Think about, this is a sample page, if anyone recognizes this page, right? This is IKEA's website. And I would like you to think about how we might be able to break this page up into individual reusable components. All right, so I want to look at this, maybe see what is reused. What might we be able to separate off into components? And we'll talk about this in a few minutes. You can also submit your thoughts to Gradescope for attendance. So we'll give 3 to 5 minutes for this, then we'll talk together. We'll begin to wrap up here Does anyone have any thoughts on this? How we might be able to conceptualize this UI as different components? Any? Yeah. Exactly. Yep. So the first thing you might notice off the bat here is that, again, we're thinking about this idea of reusability, right? And so as was mentioned, it's perfect that we end up reusing these list items, right, over and over again. So each of these list items might be able to just be one React component, maybe something like cart item. And then that cart item can just be reused multiple times instead of us having to duplicate our UI. Any other thoughts? I think that's the main one, but yeah.
Oh, because it has like events on each side of it.
Exactly. Yeah. Great point. So this is one also I believe I selected, which is these little steppers here. So this might be a great component because again, it has UI and functionality attached to it. In addition, other parts of our site, maybe outside of the cart, might use this. Like we might use this in an actual page listing. Maybe we use it somewhere else for like coupons or something, I'm not sure. So exactly, that is a perfect thing to reuse. So those are great examples. Some might also say like the icons, like maybe each of these icons are the same component, but we just pass in a different image into it. So that could be an option as well. Ultimately though, so again, that's exactly what we highlighted. In fact, here there's some other ones like a header. So we have header, and then we have shopping cart, and then inside of shopping cart, we have 3 different cart items, and inside that we have steppers. Yeah. Yes, exactly. Yeah. So in addition to this, there might be another global component this large that's for the entire page. Correct. So ultimately, though, you'll see that, and again, the main idea that I wanted to bring up here is the fact that we can create these component hierarchies where components can be nested, and we kind of create this, and maybe will I give it away here? I might have a blurb. I'll just say it creates a tree, right? It's the data structure of our UI. And again, in addition, this is directly relates to what you learn in Comp 301 with composition, and this is a major part of software engineering. And also in addition here, I believe that after this is, I thought about this, I think I have the solution. So this is actually something that you all may come up with as well. I completely forgot about this because I typically do this. It's that I just completely escape my mind, probably because I'm lecturing it. So very small technicality here. The for each function doesn't actually return what's inside of it, right? It just runs it like a loop. A map is a function that actually goes over every element and then returns. So in this case, I'm trying to return a React component every time. So if I change this to map, it should probably work. And there we go. So now map works. And you can see here that if I think I need to rerun my page here because it is, let's see, is there something? I'm going to copy this should actually not be any error with the actual code. I think this is just an error with the web container breaking. So let's see here. Cannot find module. Yeah, it's installing. Let's see if it fixes itself. There we go, finally. Okay, so again, that was not an error there. That was just Stack was breaking. So you can see here that we've looped over each of these people. I can add more, so like David is here. I can add him, and you'll see that it just adds a new element. So this allows us to duplicate using a loop, just like how we typically do, our UI for each individual element rather than having to create an individual one for each. Yeah. Good question. So actually, no. The reason why, and this is what I forgot. So the thing is if we kind of think about this as its own statement, right? So what we put in here into these parentheses can or needs to essentially equate to a React component. And so if you call for each, no matter what, as a built-in JavaScript function, it never returns. So it'll always be void. For example, again, if I will go into names.forEach, I believe it should say, whoops, names.forEach. And if I highlight over this, you'll see that the return type of my function is void. Meanwhile, if I do a map instead, and I bring this back, map's return type is in this case, it is a list of elements. Yeah. For each is mainly used inside of just TypeScript. So like it's basically another way of writing a regular for loop that just repeats a certain block for every element. Yeah, so it's just another way of writing a for loop. I forgot about that nuance there. All right. Perfect. So it does work. You just have to use map instead of for each, and that should be a teachable moment for you all as well to remember not to use for each for that reason. All right. Where is my? Well, I lost my tool, I think. Oh no, here it is. Okay, perfect. So another example is on the official documentation. So if you go to this thinking in a React, this is again part of the documentation that you will read as part of the reading. You can see here again that it talks about breaking a UI into different components. For example, here I have a very similar idea. It's a product list, but I can have these individual product rows, and then that is like iterated over in a product table, et cetera. And so that's kind of our same type of idea of breaking UI into individual components and then creating these components and then composing them together. Okay? Perfect. So all in all, as we have kind of seen, and we're going to see even more, because right now the only amount of functionality that I showed in this example was just a event handler, but we're going to be going more into this on Thursday, and you'll see this in the reading as to why React components are so useful for managing our data and functionality. But you can kind of see that right now we have reduced our files, our number of files, down from 3, right? We started out with 3 individual ones, one for our view or HTML, one for styling CSS, one for a functionality TypeScript. And we have now reduced this down to having one TSX or JSX file that is associated with a React component. And that React component has both the UI and the functionality, right? And then in addition, we also have a CSS file that's needed for our styling. And the way that this would work is you just import the CSS file into a React component just like you would with a regular import statement. So there would be import and then like /styles.css, like so. And this has ultimately a very positive effect on our developer experience, because now all of the functionality in UI for our piece of UI is contained in one place. So we don't need to have to kind of go into all these different files, go through, as we saw in A02, 3 different files just to figure out how, a piece of our view is actually working. You can just have one file for your component. You can have your UI and your functionality in one place. But there's still one thing that would be nice to combine, which is also this step, our styling and our view and functionality, right? Because what we're saying is we've gone from having a separate HTML and CSS file to now just having a CSS file along with our React component. And CSS, and you probably have felt this as well as you're working with it over time. Maybe in another class, I know if you took 590 with Chris, I believe that project used Angular so that you saw a lot of HTML and CSS as separate files, right? There are issues with it. It's annoying for different reasons in terms of our developer experience. The first one is having to switch between files a lot. So you're trying to edit a UI to make it look a certain way. You're constantly having to switch back and forth between your CSS and your HTML, which is difficult. But more so, you have to manage a bunch of these HTML, or you have to manage a bunch of these random CSS classes. These are CSS classes that you have made, or you've given a bunch of elements a certain class. You have to then go and apply some styles to it. And this scales very poorly, because if you have thousands of HTML elements, you might have hundreds and hundreds of CSS classes. If you try to go back after the fact to edit that project it becomes very difficult to know what CSS is really affecting what, and the fact that you can have like CSS from a higher, like a top level component affecting the styling of something inside of it, and it just becomes really, really, really hard to see where what styles are being affected on what element. Right, so that is a fundamental issue, especially as we scale these applications. And so again, as we talked about in the beginning of class today, and as we will continue to talk about throughout the semester, is that we add these different packages, these different libraries or frameworks into our environment to make certain things easier for us as developers. We added TypeScript to make it easier for us to catch type errors as we develop our apps. We added React to better handle creating user interfaces and also managing state, which we'll see next time. And so these frameworks have primarily been TypeScript based, where we are essentially augmenting JavaScript and TypeScript in some way to make it easier for us. But we can also install tools and frameworks that affect other parts of our app as well, including CSS. So just like we have been installing different things to make coding in TypeScript easier, we can install things to make CSS easier. And this is where we're going to be introducing something where we go from our 3 files to 2 files, and we can just go to 1 file where we combine our UI, our styling, and our functionality all into 1 file, which makes it really, really easy and nice to work with. And this is called Tailwind. So Tailwind is a CSS framework, and it provides a bunch of built-in styling classes that we can apply directly to our markup. So in this case, HTML or TSX. We'll show some examples in a moment, but it essentially allows us to just directly apply styles to our elements. We do not need to worry about maintaining hundreds of different CSS classes. We don't need to worry about all these different files and connecting everything. We can just apply the styles, and then the element that we say that we add a style on, that element will just get styled directly. And it ultimately helps us to remove that extra CSS file dependency. And we just go down to having 1 single file for our React component, and that will handle everything in 1 file. And so Tailwind is one of the largest and most widely used CSS frameworks out there. It's extremely, extremely powerful. There's really not any downside to using it, as we'll see in a moment. There are a lot of different companies that use it as well. So I know NASA is one, OpenAI I know uses it, Google and many other companies use it because, again, it helps to just improve the overall developer experience. Okay. So how it works, and I'm going to show I'm going to go in here to the website so you can kind of see what this will look like. So you'll see here that on the left, I have some styling or my component, and then the right, I have my actual UI. And you'll see that what this is like is that we add, and again, I know it's hard to see, but unfortunately, there's no way to make this light on the website. We add into the class section a bunch of these predefined classes that match to different styles. And so it essentially allows us to just directly to an element add in styles, and it will then be styled according to the specification. And as we add those styles, they will change our UI. There's a huge library or like a docs page that really discusses all of the different styles that Tailwind adds. Right? There are a lot of different things, and they're nicely organized. So things like text, right? So font size, font family, you can click on it, and it tells you a bunch of the different classes in the specification that's used to, for example, increase your font size. For text SM, for small, LG for large, XL for extra large, etc. There are a few benefits to this approach. One of them is that Tailwind also is slightly opinionated regarding kind of different, each of these individual values, like large, what's extra large, what's small, is dictated by Tailwind's style guide, right? So you're essentially going to be, and you can go outside of this and use your own. So if you didn't want to use like text XL and you wanted to use something that's like 19 pixels, your style can be written as such. So you could write something like text, text, and then 19 pixels. And this will also work. So you can pass in directly values if you don't want to use their presets. But these presets are really good because they're standardized. So it helps to make your UI more consistent and improve your user experience. We'll be talking a lot about specific styling stuff in our design module, but this really helps us there. Right. In addition, another nice thing is that you'll notice as you begin using it, because again, it seems very daunting at first. You have all these different styles. Is typically there's a prefix that's associated with most of these classes of styles. Like text has a prefix. Background color would be like BG. That's like a prefix. And so everything that's associated with the background will start with BG. And so even though it seems maybe daunting at first, and of course you're welcome to always use the documentation as we use this, it'll become a lot easier to pick up as we go through and work with it. So you'll have a lot of chances to work with this in your next assignment, which we'll be releasing next week. And I think that'll also be a fun one, because you'll be recreating one of the New York Times games. So I think that'll be a lot of fun, right? Now, some of you might be wondering if you're maybe because there are a lot of people as well that I talk to regularly who maybe are less convinced about Tailwind, or especially when they see it, they're like, okay, well, this seems fine, but you also now have like these thousands of CSS classes. So doesn't that somehow make our app less, like, doesn't that add a lot of bloat, right, to our app? If you have like 1,000, 2,000 different classes, wouldn't that be a problem? And the answer is no. And in fact, using Tailwind most of the time is more optimized than using regular CSS. The reason is because Tailwind, when our app builds, so remember our build step is where we went from TypeScript right to JavaScript. We had that conversion. Well, in that same process, we can also go from Tailwind to CSS, right? That's part of our build process. And in that process, Tailwind will only keep the styles that you use and none of the other styles. So ultimately, let's say you use text like large text and maybe background color green. Those are the only two styles you use out of the thousands that they have. The CSS that is created by Tailwind will only include those two styles. The another good thing with that is then you also have no duplication, because any element on your page that uses that text small, we're not duplicating that class over and over again. It just ships one text SM class, and then all of your elements use it. And so actually, our bundle size, that CSS that it ends up producing, is really, really small, and oftentimes about as small as you can make it. And so that really helps performance and make our app faster. So actually, Tailwind does the opposite effect than what you might think. It makes your CSS often faster rather than slower. And again, I just want to highlight again what I mean by build. Right? So again, before we had our apps with HTML, TypeScript, and CSS. We built our project to put it on Vercel or on a server. And in that process, our TypeScript code gets converted into JavaScript code like so. Right? So that is part of our build step. Vite is what does that for us. Right? That is our build tool. And so then when we fetch that website, we'll get JavaScript back. All right? So with Tailwind, and I'm going to go back to that slide. How this works is we will build our project. You can see up there, I just have React component files and then our TypeScript. And just like before, Vite will convert all of our TypeScript into JavaScript, but also Tailwind will create a CSS file based on the Tailwind classes that we used. Right? And so in our configuration, so there's this file here called vite.config.ts, and in the next assignment, you can open it up. We actually add in this Tailwind plugin into Vite. So just alongside our normal TypeScript build process, we also have this Tailwind build process. And so as we build our project, we will generate a CSS. And there's a really nice animation on their website as well. Like if I open this up, and I go back down here, right? This is kind of an example. So you can see that we add styles. And as we add those styles, sorry, again, this is a little bit hard to see because it's dark. We are adding only the used CSS into our final CSS file that we create. So we never have any duplication. We don't need to worry about writing CSS, creating our own classes. Tailwind handles it, and Tailwind will create an ultimate ultimately very small CSS file containing all the styles used in the project. And you can see here that Tailwind, right, removes all used CSS when building. And in fact, sometimes, most of the time, your CSS is less than 10 KB, right? So it's a very, very, very small file. And that is really, really helpful for making our apps fast. Are there any questions here? Yeah. Nope. Yeah. Yeah.
So when there's a lot of
Yeah. Great question. So this is, again, the other, so if people who are skeptical of Tailwind, that's one of the main concerns that they have is your ultimate styling or your ultimate file. What you end up with is you have a bunch of styles attached to each element, which can look cluttered. There are a few ways, though, to remedy this. So one is the more components that you, and the more what's the word? Componentize is not really the right. I guess the more compartmentalize your app is, where you have a bunch of different components, you can have styling attached to your component. And then instead of reusing the style, you can reuse the component, right? So then you don't have to reuse a lot of that CSS. Another thing is, which might just be hiding the problem. It's like when you're cleaning your room, you just stuff everything into a closet. Is just use an extension that can kind of minimize it, and then you can show it when you want to. So that's another thing that people do. It's not necessarily the best solution to that. But in general, I think the benefits of having your styles visible there end up outweighing the negative, because when you're developing, you can very easily see, especially you can imagine when you're developing, let's say you have a lot of divs and you're using a lot of flex boxes, maybe you have like column and then you have a row inside of the column, et cetera. If you had like a regular CSS file, you might have 3 nested divs, but knowing which style is applied to which is harder to know when you're developing. But if you have Tailwind, even though all your styles are listed out, it makes it then very easy to be able to quickly glance at your component and see exactly what component does what. Right? So that's a very good question. One of the main concerns with Tailwind. In the end, again, it's up to also you as a developer. You know, some people, some apps may not use Tailwind, they might use something else. But if you follow those things, good component architecture, maybe reusing styles. You can also technically make, if you have like a really long style that you repeat a lot, you can create custom styles in Tailwind, so it abbreviates it even more. It's helpful. So using those things might help to remedy that problem. Yeah. Any other questions? All right. Let's see here. I think yeah. So again, the last arrow I forgot to show just then, even though we're using now React, we're using Tailwind. Again, key thing, ultimately, our user, when we load our website, will get HTML, JavaScript, and CSS. Even though we're adding all these layers of abstraction, all these tools to help us, in the end, what's happening under the hood, we're still getting those same 3 types of files. We're just building on different layers here. Now, one thing I'll note is that so last semester, I was able to do a demo in class, but because our classes are 75 minutes long, having a 175-minute long class dedicated to Tailwind would not have filled up the space very well. And so we introduced it here. But what I'm going to do is I'm going to release a video showing you kind of a demo of me recreating some pages on the Excel site using Tailwind and base React. So you can see an example of how would somebody maybe go from traditional CSS or just looking at a page and actually writing Tailwind to create those styles. So with that video plus we'll have some other resources posted and the kind of description in the next assignment. You will all have the chance to really build this up. I will say ahead of time, because just to put this out there already, on any future exam, any future thing, we're not going to ask about Tailwind in terms of Tailwind styling. So you don't need to memorize it. It's just something that, again, is a tool we're going to use, and so it makes it easier for us to style. But I don't want you to get too hung up over like memorizing each of these individual classes. Okay? So again, back to where we kind of were, right? We talked about React, where we introduced React for making our UI composable. Next time on Thursday, and you also get to see this in the second part of the reading, you will learn about how we will better manage the data UI connection in our app using features of React. right? So I think we can end a little bit early for once today. So if you have any questions, feel free to ask me. You can send me an email or come to office hours. We'll see you all on Thursday.